We have a functions question, and we're given a function, told its domain that's valid for all real values of x, but we're not told what c is. And then we're told the range, and we have to work out c. First thing is that this is a negative quadratic, so it's going to be an unhappy quadratic, and it says the range is f of x is less than or equal to 19. So basically the maximum is going to be 19, this point here. Now there's two ways to work out the maximum for a quadratic, or at least two ways, but two ways traditionally done in A level, and that is firstly to try and complete the square. So f of x is going to equal minus x squared plus 8x plus c. And to complete the square on this negative, you basically take the negative out. Just like if you had a 4, you'd factorize the 4 out of the x squared term and the x term. So I'm going to get x squared minus 8x. Right, next I'm going to get x minus 4 all squared by halving that 8 at the moment. I get x squared minus 8x plus 16, so I need to minus 16. Which is going to give me minus x minus 4 squared plus 16 plus c. And we can use this to work out the maximum because this thing here is always going to be less than or equal to 0. And so the thing as a whole, the biggest it could ever be would be c plus 16. And therefore c plus 16 is the maximum, and that's going to equal 19. And therefore c is equal to 3. Okay, because the maximum, let me just say, is going to be at 4c plus 16. So basically, I could also just like write that down and then equate it to 19. Now, a second way to do this question, I think it's worth talking about, is especially if you really don't like completing the square, and here completing the square with an unknown, is to differentiate. So differentiation always allows you to find the stationary point of any curve, whether it's a quadratic or something else. So we get f dash x is minus 2x plus 8, and then the c disappears. I've differentiated this one. And it's going to equal 0 for stationary points, which in this case we know is a maximum. And then I'm going to get x is equal to 4 by solving this equation. And if I put it back in to work out the, I know the maximum is 19, so then I would say that minus 16 plus 32 plus c is equal to 19. And from that, I'm also going to get that c is 3. Okay, worth seeing that. You might prefer that method. It's a bit shorter in this particular case. I'd say, become familiar with both. Then in part 2, we're given instead that f of 2 is 8 and asked to find the possible values of c. Okay, so let's just remind ourselves, we're back to f of x equaling minus x squared plus 8x plus c. And c is not 3 now, it's going to be something else. So f of 2 is 8. Now what you don't need to do is work out f of x. We can just actually work out f of 2 and then substitute that in place of f of 2. So it's going to be minus 4 plus 16 plus c, which actually gives c plus 12. So then f of 2 is going to be f of c plus 12, and that I can now substitute that in is going to be minus c plus 12 squared plus 8 times c plus 12 plus c. Remember, that is equal to 8. All right, well, it almost looks like a hidden quadratic in c plus 12, but I've got a c there, so I'm going to have to expand this. Keep the minus, I'm going to get c squared plus 24c plus 144. And then expand this one, 8c plus 96 plus c equals 8. Minus c squared minus 24c minus 144 plus 8c. I might minus the 8, I don't know, just to collect it. So plus, it's going to be 88 plus c equals 0. Minus c squared, it's going to be minus 16 c. Dealt with that, that, and that. Oh, sorry, I missed another c, which is going to make it minus 15c. And then minus 144 plus 88, 12, that's going to be 56, minus 56. So c squared plus 15c plus 56 equals 0. And let's factorize it. C plus 7 and c plus 8 is equal to 0. So it does even say possible values of c. There's no restriction. So we're going to get two values. C equals minus 7 or minus 8. Those two values of c will give us, when we compose the function with itself and put 2 in, will give us 8.